Thanks for watching. This is video number 8 in my series on how to design a Telecaster in Fusion 360. And in this episode, we're going to create the Toolpaths to cut a fretboard on a CNC. So if you haven't seen the earlier videos, I suggest checking those out first. At the very least, watch the video on modeling a fretboard. If you click on the info button in the upper right corner, that will take you to the earlier videos. And if you have any questions or comments, please leave them and I will get back to you. And if you want to see more videos like this, press subscribe. And if you like this video, please give it a thumbs up. Unless you're a cam expert, Fusion Cam really requires a lot of experimentation. So what I'm going to do in this video is show you what I've come up with for Toolpaths and review all the critical settings. I'm not going to take you through a step-by-step because this would be a very long video and I would fumble through it. So we're just going to go to an existing setup and discuss it. So the first thing you would do is obviously you want to get into your manufacturing workspace. I would suggest hiding everything that isn't going to be manufactured in this particular setup. So I'm going to hide my nut, truss rod, body, neck, and scale. So I have just the fretboard visible here. And I'm going to go to my manufacturing workspace. So you would start out by creating a setup. I've got one here, but if you right-click on Setup and do a New Setup, that's going to take you to a dialog box that will allow you to create a setup, obviously. So I'm going to cancel out of that and just edit my existing setup and show you how I did this. So one little trick here is to widen this dialog box so that you see the words on the top here of the tabs. And if anything down here in the dialog box is getting truncated, you probably want to see it for a full description. So I like to make this thing pretty wide. Okay, so machine, you would select obviously your machine. The operation is milling. The work coordinate system we're going to come back to after we work on the stock, but first we're going to select what part do we want to do our cam for. So if we come in here, you can see we've got this big block and our fretboard is visible. So with this button being blue, I can actually click on the fretboard itself. And then that tells Fusion what we're going to model. If other things were visible in our model, for instance, I'm going to make the neck visible. Once we pick just the fretboard, then Fusion is automatically going to hide the other components because we've told the setup, basically, the only thing we want to model is this particular body. Even if there's multiple bodies within a component, you can select an individual body. For instance, in the fretboard, I've got a couple of bodies here. This one I was using just temporarily to extrude the fret slots down to. So I don't have to specifically hide it here. I can go to my body and selection and just click here and say, okay, that's the only body that I want to model. And now if well, that actually didn't work. So I'm gonna hide it here, and you can see now our setup is just showing the fretboard. Okay, so I'm going to collapse that down. All right, so let's go back into our setup and look at some of the other settings in there. If we go to stock, we can see that there's different modes for stock. You can do a fixed size box, a relative box. You could actually model in the design space your own stock, which sometimes is good to do, but in this case we really don't need to do it. So I picked a fixed size box and I picked a length, an X dimension of 20 inches, and I centered the model within there. So if we look at this from the side and we zoom in a little bit, you can see that the fretboard is centered within this yellow stock. Okay. In the other direction, I picked a width of 4. It may seem a little excessive, but if we go down to 3, for instance, I don't have enough room around the perimeter to hold this down and to allow my bit that's cutting around the perimeter of the fretboard to clear my clamps. So I figure why not put a little bit extra here. So I've got 4 inches of stock. The height I set actually to a 1/4 inch, which is the height of our fretboard. So basically what I did when building this was to leave an extra 30/2 of an inch in my stock in reality and just set this to a 1/4 inch. And this doesn't really matter because our Z height and our model are both 1/4 inch, but I left that to center. And so we're going to have a little bit of extra material to let the CNC radius cut this on the top, but I didn't even tell Fusion that, you know, the stock was a little bit bigger. Really no need to do that. Okay, so that's our stock. If we go back to the Setup tab, let's now talk about the work coordinate system. So you can use this stock box point to pick it, or you could pick the model origin, which is way back here. You can pick particular axes. I like to actually use this setting where you select your coordinate system yourself and then get a stock box point. Which I'm not seeing here. Model orientation. Okay, I've got to go to model orientation and then do a stock box point. Okay, so then you can see that all of these points show up on our stock, either the center top, center bottom, center center. You know, you can see that all the way around the perimeter we've got points that we can select for our coordinate system. The reason that I picked this coordinate system is I want to touch off on my spoil board. That allows me to get an extra 30/2 that I was talking about before on my stock and not have to screw the whole thing up when I touch off on the top of this stock. So instead I'm going to touch off my Z coordinate on my spoil board. Z is always up. In my case, X is pointing the long distance on my CNC. And you can flip these around by clicking on these arrows if it's not set up properly. So anyway, I want this in the center of my stock. I want my Z up. I want my X, the long distance here. So that's my work coordinate system, and I'm going to click on OK. All right, now another thing is I like to view this the way I'd be viewing it from the CNC machine. If I just go to home here, it's not necessarily the way I want to view it. You know, say it came in like this, and I'm standing in the CNC machine over here. So what I do is I actually go to my named views, and I make a view that's for my CNC. Basically just, you know, set my camera the way I want and do a new named view, and I'm going to call this CNC top. So then when you are switching between your different setups, once you have multiple setups here, you can right click and associate a view, which is this CNC top view, and then when I click on this visibility button, Fusion will automatically go to that view. So that's very handy. You know, in future videos, we're going to start working on the top and bottom of the neck and the body, and we can have another view right here. We could go up and make a new named view, and then when we go to our setup, it would flip the part over automatically for us. So I always like to do that. Okay, so that's the major settings here for our setups. I also like to rename this setup. You know, it started at setup 1. You know, I can slow double click on this and put a custom name in. So this is my fretboard top setup. You can see now that I'm getting a bunch of red exclamation points, arrows, and it's saying if I hover over that arrow that the toolpath is out of date. basically I did, we changed what we selected in the model. So if I right click on the setup itself, I can do a generate, which is going to regenerate. So Fusion's going to refigure out all of these toolpaths. And you can see when it finishes here. So pretty quickly it went through all of them. Okay, so we've got our stock visible. These little visibility buttons are showing our toolpaths. So if I hide everything, one by one I can show the toolpath here, and these are actually tabs that it's stepping over. But let me just go through all of these one by one. So that was our perimeter, the first one. This is a top roughing operation. You can see it's cutting a little bit along the edges here, and it's also cutting this little step down to the headstock. If I hide that and unhide this one, these are spiraling down, these toolpaths spiraling down to cut our marker holes. Hide that. Then I'm going to unhide this one, which is the nut slot operation, cutting the slot here for our nut. Then the next operation is a finishing toolpath, and you can see there's lots of paths here, so there's a very small step over to get a nice finish on the top. And then the final toolpath is, you can't really see it because it's down in these slots, there are fret slots. There's a toolpath down inside there. Okay, so let's analyze each one of those. So the first toolpath is this perimeter cut. If I make that visible, you can kind of see what's happening here. I've got a 1/4 inch bit, and it's cutting around the perimeter of the fretboard. And I'm having tabs left on so the part doesn't go flying off. The reason the perimeter is cut first is actually to make enough room for the top cut so that the top cut doesn't collide with existing stock here. So I'm clicking on perimeter, I'm going to simulate, and in this simulate box, the way I have it set up is I like to have this stock, you can turn your stock on and off, and this is your model here. I like to have the stock on, and I like this comparison mode. There are different modes here where you can just see the material itself. I'll go ahead and cut, and you can see that it's exposing, it's cutting into the stock material. But if you go to comparison here, there's 3 colors in comparison. There's green, which means that's actually exposing the 3D model. Blue, which is stock areas that haven't been cut into or haven't been cut down to the model. And then there's red, which means it's actually cutting a little bit too far. I'm not really sure why there's red there because there's no model there. But if we were to plunge this down into the model and cut beyond the top of the model, we would see red. So that's a great way to see if you've cut far enough or not far enough. So we simulated this perimeter. I'm going to do that again and actually kind of slow things down. And you can see what's happening here. It's cutting around the perimeter. And let me pick up the speed a little bit. And it's actually doing 2 passes around the outside and 2 passes in depth, and it's leaving these tabs. The reason I did 2 passes around the outside was to leave enough room for our roundover bit when it's, rounding over, our ball nose bit, when it's rounding over the radius of the neck, not to collide with existing stock. So it's kind of freeing up space for that. And then eventually at the end, we can cut these tabs off and finish them. Okay, so let's look at this toolpath in depth. So I'm going to double click on this little icon here, which allows us to edit the toolpath. You can see that I've selected a 1/4 inch bit. To select a bit, you go to your to a database of tools. I like to use these Amana tools. They are expensive, but one of the one of the reasons I do that is they have a comprehensive database of feeds and speeds for all of the bits that they sell, and then I can copy the ones that I've purchased into my own library. So I would actually pick something out of my library. In this case, I picked a 1/4 inch flat to do this perimeter cut. Now this is a 2D contour operation. I should have said that first. So when I created this, and I'll show you how you do that, basically you can either right click on your setup, or with your setup selected, just go up here and pick one of your 2D toolpaths. 2D contour is the one that we're using right now. So back in this 2D contour, we've got the 1/4 inch tool selected. The feeds and speeds I got out of the tool database is where they're going to start. I actually limited this. It was 180 inches per minute. I limited my cutting rate here to 120 inches per minute. 180 was pushing it a little bit. Now, for geometry, basically what I selected here, if I turn my geometry off, let's see, I'm going to X out there. So basically I want this perimeter to be cut around the outside. So I could either click on this upper perimeter, but basically that's going to not get us all the way around the outside. So what I did is I clicked on the bottom one right here. And that's perfect. So that's all the way around our perimeter, including this little notch that exposes the spoke wheel on our truss rod. Okay. And our arrow is pointing, our arrow means it's cutting on the outside of that contour. If I clicked on that arrow, now that's cutting on the inside, which would really screw us up. So by default, I believe that came up on the outside, but if you need to change that, just click on the arrow. You can see that there are tabs here. So in geometry, if you go down to this tab section, if I turn that off, you see our tabs go away. If I turn that back on, you can either select the tabs yourself. You would change this to at points, and then you would kind of hover over here and click where you want tabs. In this case, it was fine for me to leave this to by distance, and then the distance, you know, if I did a tab every 4 inches, you can see I've got 4 tabs along each side. Now if I do every 3 inches, I'm getting 5 tabs. 5 is probably a little overkill, but I'd rather have it held down pretty well. You notice there's no tabs here. I think the distance of 3 inches, this automatic distance, didn't allow a tab to be created on either end, which works out fine for us. Now you also have a tab width and a tab height. I set this to a 1/4 inch of width, and the height looks like it's 1/8 of an inch. So that's a good meaty tab, but if you need to change those settings, those are there. Okay, so basically that's all we did for geometry. We selected this chain right here, this outer perimeter, by going to selected contours and then clicking here. And we turned on our tabs, and that's all I did in that dialog box. Now in the heights dialog box, basically working from the bottom up, I want to set this, our bottom height, which is the extent of the CNC cutting down into the material, to the bottom of the model, which is basically this surface right here. I added an additional offset of 5 thousandths. So I wanted to cut beyond it. So you can see that I want to go down, so it's negative 5 thousandths to cut through, to make sure I'm cutting all the way through the material. Okay, so the top of our cut is where the cut's going to start. And you can see if you hover over any of these options in your CAM dialog box, you'll get a nice explanation of things, or at least an explanation. It's not always easy to understand what it is. But anyway, so our cutting is going to start at the stock top. Now our feed height, retract height, and clearance height, I've had trouble kind of understanding some of the differences between those. At one point I thought retract height had to be set way up here. I'm realizing now it doesn't. In order to clear your hold downs, you really, I think my CNC machine anyway is going to retract quite a bit and then move back to its homing position once it's done with its cutting. So I think setting these to 1/4 inch each is fine. Now in passes, remember I said it took 2 passes around the perimeter. So the way you do that is to do roughing passes or finishing passes. So in this case, there's really no difference between roughing and finishing passes if you just do one. So I'm going to consider this a finishing pass. Now the downside of that is it's not going to use the speed that you set when you did your tool here. So if you really want this at 120 inches per minute, I'm going to set my finishing pass here to 120 inches per minute. But I'm going to have multiple finishing passes. So I'm going to set this for 2, and that, I have to first check this, and then I can set my step over. Since it's a 1/4 inch bit, I'm going to step over by just 1/16 of an inch. I just want a little bit of extra material going around the outside. And the other part of this passes dialog box that I'm going to use are multiple depths. Because I've got a 1/4 inch bit, I don't want to cut a 1/4 inch deep. I want to cut about half the diameter. So I set that to 1/8 here. So that's going to give me my 2 step downs. Okay. And linking here, I don't think I did anything. I just took the defaults. And I'm going to do an OK. So now the toolpath is generated, and you can see it here with this visibility turned on. And now we're going to simulate and see what we get. So this toolpath is selected. I'm going to click on the simulate button. We're in our comparison mode. I'll just hit play here, and you can control the speed. And you can see it's doing its 2 passes around the outside, and it's also doing 2 depths. And if we look at it from the top, we can see that we have our tabs set. So that looks pretty good. I don't think I'm going to do any changes to that. So I'm going to close that. And that was our first tool. So the next operation is a top roughing operation. You can see that it's cutting a little bit along the edges of this radiused fretboard, and it's also cutting over here, this transition down to the headstock. So I'm actually going to hide the perimeter and show the top toolpath. Okay, so how did we generate that? So basically what I did was I selected a 3D adaptive clearing. That's what this toolpath is. So if I go in and edit it, I'm still using the 1/4 inch bit. For geometry, I didn't select anything. The 3D toolpaths will look at your model and basically try to cut it out accurately. And in this case, it did a great job. Okay, so the heights really don't apply because it's using the model to do the height. I've got the model bottom as my bottom height. I've got the stock top as my stock height. Retract, I'm going to do a 1/4 inch here. And clearance, an additional 1/4 inch from the retract. In my passes, I don't need to do much of anything here except stock to leave. I want to make sure stock to leave is turned on, and I think by default in a 3D adaptive, Fusion does put these values in. So basically I'm leaving a little bit of the model to be cut in a future operation. So I'm going to go to my linking, and I don't think I changed anything there. Actually, let's see if we can hold this down. Minimal retraction is going to keep our bit from retracting as much. So now I'm going to do an OK. We'll generate this tool path, and let's go ahead and simulate it. So when you simulate an operation that's not the first one, it's going to basically pre-cut all of the other tool paths before it. So it shows you what the stock is in its current situation. So I'm going to go ahead and play that. That went a little fast. Let me move the speed down. And I'm going to reset here. Let's zoom in on this area here. And when I hit play, you can see it starts to rough this area out. Now you can see that the tool turns red a couple of times. That's indicating a collision with stock. And you'll see down here in this toolbar, there's two little red areas here. That's a rapid collision with stock. Another way you can detect that, what I like to do, is turn on stop on collision. So now if I go back to the beginning, I hit play, basically wherever there's a high-speed collision with stock, right there, the playhead's going to stop. I can hit play again, and these are all collisions here. So I'm hitting play until I get past that. Then it's going to continue on until it does another rapid collision with stock. I'm not too concerned about this. I mean, this is obviously not our model here. So I'm going to turn stop on collision off, and then we can proceed. But I want to show you what's getting cut here, which is very little. So I'm really not worried about that. And now it's coming down and doing our roughing on the edges of this, not the edges, but the outer portions of our fretboard. Speed this up a little bit. Okay, so that's nice. It's just hogging out a little bit of material that will be finished in a future toolpath. Okay, so the next toolpath we're going to essentially spiral down, not using a drill operation, but we're going to spiral down and cut these holes for our markers. The reason we're doing that before we finish the radiusing of the tool of the fretboard is we can kind of finish these areas off so they'll be nice and smooth. Okay, so what did we do to do that? If I double click here, you can see that I actually used a 2D pocket operation. Okay, so that is in our 2D menu, 2D pocket. Okay, so taking a look at that toolpath, I'm going to edit it. I need a smaller bit to be able to get in these areas, so I picked an 1/8 inch flat end mill. Now in our geometry, it's saying I've selected 10 pockets. So I'm going to turn this selection off and show you how I selected these. I actually clicked on the bottom of the pocket, and thereby, you know, Fusion will know how deep to cut. Instead of clicking on the top, you know, perimeter here, I want to make sure I get the bottom on all these cases. And then if I wanted to overcut this or undercut this, I can do a stock to leave and control that, whereas I wouldn't be able to. Oops, see, this one's wrong. So I'm going to shift click on that and make sure I get the bottom. Okay. So I've got my 10 markers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 selected here. My heights. Now the bottom height, in this case, I think this automatically defaulted, but if not, you want to have selected contour. So in other words, it's going to cut down to the contour that I selected when I was doing the geometry. And the top height is our stock top. That's where it's going to start the cutting. And then it's going to go up 0.2, 0.2, and I'll set this to 0.2 also. Okay, so our passes, The only thing of significance here is, do we want a little bit of stock to leave here? So this is basically, you know, how well our inlay is going to fit here. We can leave a little bit of material. I like to turn this off initially anyway, even if I want to have this on and do my simulation to make sure that I've got everything set up and it's exposing green. It's exposing the model when it starts doing the simulation. So I've got markers selected. I'm going to go to simulation, and you see that Fusion is going to spiral down. Let me turn the speed way down. We'll go back to the beginning here. So Fusion is spiraling down instead of just plunging all at once. You see it's actually starting to spiral a little bit too high here, but so now it's starting to cut, and you can see as it's cutting, it's exposing green on the walls. If I had some stock to leave axially, I'll show you that. Let me go back into the toolpath, double click here, and if we go to our passes and turn on our stock to leave, axial is the bottom, the floor, radial is the walls or the side. Let me set this to 0 just as a demonstration here. So we're going to cut down to the bottom of these pockets, but we're going to leave 20 thou around the outside of the pocket. And now when you do your simulation, we should see as this bit spirals down, once it starts cutting in the material, right here, you can see that there's blue left around the outside. So if we wanted to undercut this, that's how we would do it. And now it's going all the way down to the bottom of the floor. So that was controlled, if we get back in our toolpath, by our passes, our stock to leave, our 20 thou, and nothing on the bottom. So an easy way to, even if you want to leave that additional stock, I would suggest turning this off, do the simulation, make sure you're cutting properly, you know, to your green in your comparison, and then go ahead and turn your stock to leave back on. Okay, I think that's all we need to do in our markers toolpath. So the next toolpath, we're going to cut the nut slot. So let me zoom out, and I'm going to hide all these other toolpaths, and I'll show this one. So here is our nut slot. We're actually going to use the same 1" bit that we used to cut our fret markers. And this is a 2D pocket, I believe. So let me double click here. Yep, this is a 2D pocket. Okay, so let's go over the particulars of that. We're using a 1/16 of an inch bit. Okay, so I guess the 1/8 of an inch bit. Oh, that's right. This is an 1/8 of an inch. And you would think that Fusion would be able to cut a pocket that's an 1/8 of an inch with an 1/8 of an inch bit, but it actually wants a little bit extra. So you've got to go down to a smaller bit or use a trace toolpath. And I'll show you a trace toolpath when we do the fret slots. So I chose to do a bit change here. I picked a 1/16 of an inch bit. Now our geometry selection is pretty easy. All we have to do is hover over the bottom of this pocket and click. Our heights, we're going to go down to this selected contour. We're starting at stock top, and we're setting all these retract heights to 0.2, our feed height, retract, and clearance. Passes, this is a 1/16 of an inch bit, so I don't want to go down too aggressively and snap this bit off. So I am going to do multiple depths of 0.0125 as our step down. Stock to leave, radially around the walls. I'm leaving 10 thou. So I want a nice tight fit here. I can come back and run this toolpath a second time and turn my stock to leave off if the initial cut isn't big enough. And I think that's the highlights of that toolpath. So let's go ahead and simulate that. So we've got our 1/16 of an inch bit. I'm going to slow this down a little bit. Press play. And you can see we're taking multiple swipes at this. Now remember that we have stock to leave on the walls. So I actually want to at least simulate it once with stock to leave turned off to make sure that the toolpath the geometry was properly selected, and then we can turn it back on. So we've got green on our floor, we have blue on our walls. Let's go ahead and edit the toolpath again and go to our passes and just turn stock to leave off. It's not going to change these values, but it's essentially going to override them and set it to 0. So now when we simulate, I can speed this up a little bit. You can see that we have green on our sidewalls and green on the floor. Okay, so it's doing the right thing, so I'm going to go back in and turn my stock to leave on. That's funny, when I do that, it defaults. So axially, I'm going to set this to 0. And I think I'm not sure what I had the setting here for my stock to leave on the sides. So I'm going to set that to 10 thou. Okay. All right, so that was our nut slot toolpath. So the next toolpath, we're going to finish the top off. So we want a ball nose bit, and we want one of our finishing toolpaths, and those are in our 3D selection. We could pick either parallel or scallop. Scallop is going to start on the outside of our fretboard and work its way inward. Parallel is just going to go back and forth in the long direction if we set it up right. So I actually picked parallel. So I'm going to double click here. Here's my parallel toolpath. I selected a 3/8 of an inch ball nose bit because I've got one, why not use the widest ball nose you have? You're going to require less step over that way. Okay, so as far as the geometry, basically all I had to do was pick the machining boundary, which is going to be right here. So anything within this machining boundary, again, this being a 3D toolpath, Fusion's going to figure out what to do. And in this case, what we want it to do is to surface the top and actually step down and surface this transition area too. Okay. So in our passes, I'm sorry, in our depths, our heights, we're going down to the model bottom. We're starting at the stock top. Again, this is all going to be figured out pretty automatically by our 3D toolpaths. I'm going to set the retract to I think I was doing 0.25 on some of these at least. So I'll do a 1/4 inch on our retract height and our clearance height. Now our passes in parallel, if your parallel toolpath is always going to go along your x-axis, so if the x-axis of your machine was going in the opposite direction and you're going back and forth this way, you can change that right here in pass direction, set that to 90 degrees. Now here's another important part. This is our step over. So I'm going to set this step over to 10 thou. So a very small step over. And smoothing, I turned on smoothing. I'm not sure it's needed in this parallel toolpath. So I'm going to turn that off. And let's go ahead and simulate. Okay, so you can see we've got a very dense toolpath here, very small step over. So let's go ahead and simulate it. And you can see that it's, another setting that I should have told you about is I've got this set up to go in multiple directions. So it's cutting in each direction, which is decreasing our cutting time. Let me go ahead and go into the dialog box and show you that. So in our passes, where is that? Oh, here it is, direction both ways. It may actually default to one way, I'm not sure, but make sure that's set to both ways. Okay, so getting back in our simulation, we should be exposing green. This is the model being thoroughly finished here. Okay, so I'm going to pick up speed a little bit. And now you can see that it's actually dropping down over this edge. And a little bit of blue, a little bit is not being cut here. That didn't turn out to be a problem. But let me show you another setting that I believe I did that got us much closer to that. I think by default, this contact point boundary is not turned on. Okay. And there's another thing, this additional offset is probably set to 0. So I want to show you these two fixes that were made. Okay. So now when we simulate this, by default, this is what the parallel toolpath is going to do. Let's speed it up a little bit. Okay, now you can see that this bit is not getting anywhere close to the bottom of this transition. Okay, so if we kind of go to the side here and see if we can see what it's doing as it drops down. Slow it down a little bit. It's basically saying, okay, I don't want the bit to go beyond the geometry that's getting automatically selected. So it's keeping the bit within the geometry area, and thereby it's not getting down far enough. So it's saying, okay, this bit can't extend beyond this boundary. Here it comes here. I'll slow it down next time. Where is it? Yep. There it is. I'm going to actually scrub back here so we can get the bit back in that position. Come on. I'm going to try to stop it right there. Okay, so I'm going to scrub my timeline back a little bit. And you can see that the bit doesn't want to go, actually the center of the bit isn't going beyond this boundary. So how is that being controlled? Let's go back into our toolpath. And if we go into geometry, we're saying, okay, tool containment, the tool center is on boundary. So that the middle of that ball nose bit didn't go any farther than this edge right here. And that's not enough to cut this transition. So you might think, okay, what if we try this tool outside the boundary? So now it's going to drop down, and it looks like it's going to cut this transition fine, but it's actually going to create another problem. So let me speed this up. And what that setting allowed the bit to do is actually come in and cut the edges of this fretboard, which we don't want it to do. So what's the solution here? We're going to go back to, let me edit our toolpath again. And in the geometry tab, I'm going to keep the center, tool center on the boundary. I don't want the tool center to go beyond this green boundary. And I'm going to turn contact point boundary on. And this is actually one of their helpful little dialog boxes that shows when it's enabled. You can see the left one, right? Well, I can't move my mouse, but let me get that to pop up again. The left drawing there, the one that says disabled, you can see that's what was happening to us. The center of that tool wouldn't go beyond the edge of our fretboard, and now when it's enabled, you can see that it's going to go down far enough so that it finishes the cut there. So we've got tool center on boundary, and we've got our contact boundary checked. So now when we simulate, let's see. You see, now we get the best of both worlds. We're getting it down almost to the bottom here, and it's not cutting into the sides. Okay. Now, if we look at our toolpath here, let's close our simulation down and just make our toolpath visible here. You're seeing a whole bunch of extra jazz going on the outside here and here. And I found out from another guy's video how to control that. And that's in the tolerance setting. So if we go back in and we go to our passes, you're going to see a tolerance, which is something about how far outside of the STL model it's generated to do the cam work. I honestly don't understand it, but this tolerance figure, if you set this as a negative additional offset, that will fix the problem. So we can either remember that it's 0.0004 inches, or there's actually a variable that controls this tolerance. And if I hold down my shift key and hover in this box, now it's saying on the bottom of this little pop-up window, I've got a parameter name of tolerance, lowercase t. So I can go in here and set my additional offset to a negative tolerance, and then press enter. Now, let's see what happens. Now all of that additional toolpath that's outside of our boundary goes away. I'm not quite sure why Fusion doesn't do that by default, but that fixes the problem. So let's go ahead and simulate this toolpath. Okay, and you can see that it didn't cut in right here. It's still doing a good job in our transition. But another problem that I saw here was, and let me scrub this backwards. Well, let me reset it. And I'll slow down when we're getting close to our marker holes. That the tool is actually starting to dip down into our marker holes. Right there, you can see. You see how it's dipping down a little bit into the marker holes. So, how do we solve that? So my first attempt to try to solve this problem of the dipping down into the marker holes was to go back into the toolpath and go into my geometry and use avoid surfaces to touch. And I thought, okay, if I select, say for instance, this hole right here, let's see what happens. And there's what happens. It is going to avoid going down in there, but at the same time, the bit is going to retract around my marker hole. And my experience is you're not going to get a smooth tool path around the marker hole because of that retraction and reinsertion. So I found another method to use. Let me turn that off. I'm going to turn that off. Basically what we need to do is temporarily fill these holes. So if we go back to the design workspace, we can actually seal these holes up with a surface. I'm going to turn our dots off. You know, the other thing is we've already got these dots, so I'm thinking maybe I didn't need to do that. Maybe we can actually use these dots and put those in the model because these have already been trimmed off to the radius of our fretboard. So let's try that before we try to patch these surfaces. So back in the manufacturer workspace, let's go to our model and let's open up the fretboard and make the dots visible. Okay. So now what we need to do is add that to our model in this particular toolpath, the top finish toolpath. So I'm going to open that up, and in the geometry tab in model, we're going to try to add all of those markers. So I'm going to open up my model and open up dots and open up the bodies inside the dots, and I'm going to shift click to select all of those. So I've got 10 new surfaces in the model. Okay, so now let's see if that worked. If we zoom in on this, it looks like our toolpaths are going straight over the dots and they're not dipping in. So let's go ahead and simulate. I'll zoom in around the dots. Once we get a little closer, I'm going to slow this down. Speed it up until we do. All right, now I'm going to slow it way down and see if we're dipping in. No, we're going straight across it. So that was nice. We actually used the bodies of those dots to actually fill the holes so that the toolpath does not drop into that spot. Okay, so that was a quick fix. Okay, so the final toolpath is going to be our fret slots. So let me zoom out and let's take a look at that. So basically, I've pre-created these slots, and the slot width is 0.023, which is the tang width for the frets that I'm going to be using. So that's the exact width. And again, Fusion has a problem if you define a pocket that's the same width as your tool. And I did purchase a tiny little fret cutting CNC bit that is 0.023 inches. So I'm unable to select this as the pocket to cut. So the solution is to use a trace. Let me close this up. Is to use a trace operation. And trace says that it will machine along a contour with varying Z values, which is good because we've got our curved bottom of our slot, with or without left and right compensation. So basically it's just going to follow a line. Wherever that line is, it's going to cut to that line. So what I did was, in my design, inside the fretboard, I made a sketch. And that sketch is right here. See if we can see it. Okay, so if I hover over these lines, you can see it. Basically what I did was I started with our slot sketch, which was starting at the top of the fretboard but going straight across, and I draped that down by using, let's see if I edit this sketch, we can see it. By using this project include, and I projected those lines to the top of the fretboard. So that gave them the curvature of the fretboard. And then I selected all those lines in the sketch and actually moved them down by the depth of the cut that I wanted to cut. So this sketch exists inside the fretboard, basically. and it exists at the depth that I want to cut the slots. Okay, so trace slots is the name of that sketch. So if we go back into the manufacturer workspace, that sketch is now turned on. And you can see if you go back and forth between manufacturer and design, whatever your visibility settings are, transfer back and forth. So in the fretboard, let's see, we can collapse dots up. Basically, I want to turn off this sketch on the top. Where are my sketches here? Right here. So I want to turn off my slot sketches, but I do want this trace slot to be on because we're actually going to use that to select the geometry for our trace. So let me collapse the model down, and here's our fret slot trace toolpath. So I'm going to open this up, and you can see that I've used this tiny little bit, this 0.023 bit, and the geometry that was selected were all of those lines in the sketch. So there's 21 lines for our 21 fret slots. Now the height starts at the stock top, and I'm actually starting 0.2 of an inch above stock top. Oh no, that's my retract. Sorry about that. Okay, so our feed height is the model top and 0.2 of an inch above the model top. I'm going to change that to 0 because I'm not understanding why that's not set to 0. So our feed height is going to be set at the top of the model. Well, let's go back. Maybe I had a valid reason for doing that. Let's try it at 1/10 above. See if we don't error out. Okay. So there's probably a little bit of extra back and forth here with the bit going above. But basically the idea here is this bit, when we simulate it, is going to cut down to the sketch. Okay. Now, I don't want this thing to step all the way down to that sketch. So what I did was, I'm sure I did some type of multiple depths. Here it is. So I turned on multiple depths, and I just researched online other people using this bit, and they said that this is a nice depth of cut for it, 0.012 inches. Multiplying that by the overall depth of where this sketch exists inside the fretboard, I got 5 step downs. And so let's again watch this, knowing that this is going to step down 5 times. There's 1, 2, 3. Oh, I guess it's stepping down in each way. It's going in 2 directions. So 1, 2, 3, 4, 5. I actually did 6. So it's getting all the way down to that sketch. So that's all we needed to do for that. So we actually didn't use these slots, but the nice thing is the slots are in the model, and we can actually see in our simulation whether we have cut all the way down because we have that slot in the model. So let's see. We're seeing a little bit of red here as if it's being overcut, but I think that's just an artifact of the graphics. So that's a wrap on the Toolpaths for the fretboard. I would suggest doing the fretboard cam first, even if you don't cut it first on your CNC, because it's by far the easiest of the 3 major pieces, you know, the body, the neck, and the fretboard to actually work out. I am by no means a cam expert, as you can kind of figure out after watching this video, but I, through trial and error have figured out some of this stuff. And so hopefully in the comments, people will comment on potentially better ways to do some of these toolpaths or different options that might be used to, to optimize performance or fix errors. But yeah, that's it for now.